Let's start understanding what are logarithms. Before we step into what are logarithms, we'll see what are exponents. So if I ask you what is 10 square, what do you say? You say 100. And if I ask you what is 5 cube, you would say 125. If I ask you what is 3 power 4, you would say 81. Similarly, if I ask you what is 2 power 5, you would say 32. So these are the ways how we write exponents, right? Now, if I tell you there is something called as logarithms, which gives you power. So which is log 100 to the base 10 is equal to 2. And log 125 to the base 5 is 3. Log 81 to the base 3 is 4. And log 32 to the base 2 is 5. Now if you just see here, so this 2, 3, 4, 5 all are the powers of a number, right? Now this is how logarithm is written. Now let's see how and how it is being defined and what are these 100, 10, 5 respectively. Okay, moving forward, we have the definition for logarithms. So what are logarithms and how you should write and read? So for any positive number a and b, so a comma b, these two should be greater than 0. Okay, and here b should not be equal to 1. So that is again one more condition. Okay, how do I write and read? Log a to the base b is equal to some power I'm going to get. So as if like Bahubali is there, Bahubali is going to lift this power, so which is b power x is equal to a. What is this a? A is nothing but the argument. So if you say like log 100 to the base 10 is equal to 2, how? So this 10 goes here and lifts this 2, and you get what is 10 square. So what is 10 square? You write it as 100. So this is the basics of logarithms. And how do you read? How do you write? Log a to the base b gives you power. So logarithm gives you what? Power. And here it's clearly mentioned that for any positive number, for only positive numbers, that's why I've written a comma b is greater than 0 and b is not equal to 1. Okay, so that is an important note. The base cannot be 1. Okay, moving forward, now let us try to solve this question. Write an equivalent form of logarithmic form and exponential form. So here it's given 9 power half is equal to 3. Now see, log a to the base b is equal to x. Now in exponential form, b power x is equal to a. So how it is given? Log 3 to the base 9 is nothing but half. So this is the first one answer. For the second one, log 625 to the base 5 is equal to 4. This is a given question. This 5 goes here and lifts this 4, which is equal to 625. So this is exponential form, right? So properties of logarithms. First property is we have as product rule. So product rule. Okay, so this is the first property. What we have is log a b to the same base. The base can be written as x. Okay, this is nothing but log a plus log b. Let us try to understand. So it is similar to your exponents property. A power m into a power n is nothing but a power m plus n. So it is like that only. It is a similar one. So if I try to write log, say like 32, okay, to the base 2, I can write this one as log 16 to the base 4 plus log 2 to the base 2. Okay, so this is nothing but log 2 power 4 to the base 2, the base is 2 not 4, plus log 2 to the base 2 power 1. So this 4 will come here first, and this 1 also will come here. So that's nothing but log 2 to the base 2 plus log 2 to the base 2. Here you have 4, here you have 1, which is nothing but 5 log 2 to the base 2. Now this is nothing but 1. I'll tell you how. How log 2 to the base 2 is 1. So log 2 to the base 2 is equal to say like x. Now this 2 goes and lives here. 2 power x is equal to 2. So what should be the value of x? It should be 1. So therefore 5 into 1 is 5. Okay, this is another property. Okay, and here you can simply write for this log 32 can be written as 2 power 5 to the base 2, and this 5 will come to the front. Okay, so I can write 5 log 2 to the base 2, basically 5. So your LHL and RHS both are same, right? To the next property, we have quotient rule. Okay, we have something called as second property, we have quotient rule. So what is quotient rule? You have log a by b. Log a by b, that's nothing but log a minus log b. So how do you relate to your basics? A power m divided by a power n is equal to a power m minus n. So the same concept here. Okay, log. So again, if I consider say like 16, okay, to the base 2, I can write log 32 to the base 2, okay, minus log 2 to the base 2. So this is nothing but log 2 power 4 to the base 2. This 4 will come here. So you will get 4 for the left side. For the right side, log 2 power 5 to the base 2 minus log 2 power 1 to the base 2. So this 1 will come here and this 5 will come here. Basically 5 minus 1, 4. So both LHS and RHS are the same. So how this is 16? See, I am trying to write 32 by 2. That's nothing but 16, right? Okay. So the next one is power rule. Okay, so this is the basic uh, power rule. Third one is power rule. So what this power rule tells? So you have log a to the base b. On top of this, you have say like x. So this can be brought to the left side. X log a to the base b. So this is what the power rule means. Next one, you have something as base changing. Base changing form. Okay. So I have log a to the base b. Okay. I can write this one as log a divided by log b to any base. I can keep it as x also. That's my wish. Okay. I'll give you an example. Log 16 to the base 4. Okay. I hope you know the answer now. Log 4 square to the base 4. So this 2 will come here. So you can write 2 log 4 to the base 4, which is nothing but 2. But I can write this one in another form also. Log 16 to the base 2. I told now I can choose any base. Log 4 to the base 2. Now if you try to equate, this is nothing but 4 by 2. Answer is 2. Yes. So you can change the base. It is your wish. You can change the entire base, right? So these 4 properties are very, very important.